I did number 8, and you were supposed to cross multiply and then check for extraneous solutions. So I cross multiplied the 2x plus 1 and 2x. And then I got 4x squared plus 2x. And then I did the x plus 2, and I multiplied that by x. So I got 4x squared plus 2x equals the x squared plus 2x. So I've subtracted the x squared plus 2x to the other side. And you get 3x squared equals 0. So then x has to equal 0. So I plugged in 0 as x to make sure it wasn't an extraneous solution, and it wasn't. Because 0 equals 0.
Any questions on number 8? Nice explanation, Jeremy. Why doesn't 0 get a plus or minus with it? Because it's just 0, yeah. If 0 doesn't get assigned a value. Nice job.
Well, okay.
It might be, yeah.
So Nick is going to go over number 16.
He wasn't this, he was here this week.
And you just don't have feedback anyway.
So the LCD is x squared minus 4, so you got to make all the denominators x squared minus 4. 4. Then I could combine the one side to x squared minus 4x minus 16, and then you can cross out the denominators because they're the same, and you get x squared minus 4x minus 16 equals 3x. Then you make them equal 0, and you can't factor that one, so it's a no solution.
Why is it no solution? Because the paper says so is not a good reason.
Okay. You can't find anything that would factor that. You can't nothing adds or subtracts to be negative 7 and multiplies to be negative 16.
Okay, so you said there is no way to factor it, which there isn't no way to factor it. And if you did plug it into the quadratic formula, you get an imaginary number underneath the square root. So you get a negative number. That's why there is no solution. Questions? So it's not no solution because it doesn't factor. It's no solution because if you would plug it into the quadratic formula, you would get a negative underneath the square root. Nice job. Not a negative. It's what makes the denominator zero. So you have to take the number and plug it into the denominator and see if it makes the denominator zero. That's how you know. Yes. Then it'd be a check.
Here. There.
So we are going to go over more of this today.
This is. You should have known. Did you? Yeah, it's so respiration on the right side. And also, she literally said, "You're gonna need to put some respiration on your graphic organizer after we learn in class." Yeah, she did.
So in your notes packet, if you could turn to page 25, please.
I dare you to follow that. This graphic organizer is my favorite. Trying to control the media. No, I have a sheet. I have notes. I just don't have time to do it. Do it from gym. I mean, I want to ask you to I just say
Yeah, I thought you
it's try hard.
the other thing on the back
Go to the library and asking people to around that class. We don't wanna have you united grade again. At the end of class. It's worth a shot. Alright, good. We're gonna say, oh no, fat but fit. Oh, fat. He already does. That's how he was. I still think that's how he laughed. You want this?
Yes.
You did a great job. Oh, yeah. Get started. What am I doing? I'm wasting time. You didn't even write self-restoration. I'm telling you. That's not the right paper.
Alright, so if you look at letter A, for example, 4, we're going to walk through this problem kind of like step by step just to make sure everybody's on the same page. There is a B. Mine is going to take up the whole board, but we are going to do B, so make sure you like divide, like put a line down that so that you know that you have to save space for B as well. So when you're solving an equation, we're still using the least common denominator to help us solve. But our goal is to use that least common denominator so that we can eliminate the denominator from the fraction instead of keeping it in the fraction. So our goal is to get it out of the problem instead of remaining in the problem. The first thing you have to do for any of these problems with a least common denominator, any problem that has a least common denominator, is to make sure you have it factored. So if you look at the first fraction, Sam, it says x squared minus 16. How does that factor?
X minus 4, x plus 4.
Right, so this is really x minus 4, x plus 4. So Sam, what does that mean the least common denominator is that?
X minus 4, x plus 4.
Right, so the x minus 4, x plus 4 is the least common denominator. So the process to solve an equation is to take that least common denominator and multiply both sides of the equation by the least common denominator. That keeps it equivalent. So x minus 4, x plus 4 on both sides. And if you want to place it over 1, you can. You don't have to. So after you figure out that least common denominator, the next step then is to kind of look to see what your current denominator has. How does that compare to the least common denominator? So my current denominator has an x minus 4n and x plus 4. Well, it has all of the least common denominator as part of it. So that means it doesn't need anything extra in the problem, so it just stays as 6x squared. Because this denominator is canceling with every part of the denominator that we're multiplying by. It goes away because it has all of the least common denominator. If you look at the next one, there's an x plus 4. What does the top need so that it has the least common denominator in the problem? So what's the top missing? Isabella? Right, it's missing the x minus 4. So if you multiply that, Isabella, we have 3x times x, that makes?
Negative 3x squared.
And then 3x times negative 4 is?
Negative 12.
Negative 12. That gets placed with parentheses. And that's where I think a lot of you, as I was walking around, are making maybe a tiny little mistake with that minus sign. Because whatever you multiply the 3x with, or whatever's on the top there, there's a minus sign in front of that second parenthesis. So whatever you happen to distribute or FOIL, that minus sign has to go to both terms, not just the first term, not just the 3x squared, but also the minus 12. So I'm placing parentheses around that, and that'll happen in a lot of the questions we go over today. Aaron?
So, it's not negative 3x.
It's just a 3x up here.
Okay.
The negative is in front of the fraction. Yes.
Could you just distribute the negative right now?
Sure, you can just distribute the negative right now, yeah. So it would be a minus 3x squared and a plus 12x. So then on the other side of the problem, there is an x minus 4 already in the denominator. What does the numerator need so that it has the least common denominator? So Isabella, what does it need?
X plus 4.
Right, it needs the x plus 4. So that means we have 4x plus 16. So you should not have a denominator left because you're multiplying the whole thing by this least common denominator. It's canceling out the denominator for you since you're using it on the left and the right side of the equation. So after you're done, there should be no fractions in the problem once you're multiplying by that least common denominator. Are there questions about how to get to this part? Sam?
Wait, so you don't like cross multiply once you subtract the stuff together? Like once you subtract 6x squared minus 3x, after adding those stuff, after like multiplying the stuff in each number you don't like, then cross multiply with the sign.
There's no cross multiplying because the equation has 3 pieces to it. And each one of these denominators, like none of them are the same, so there's no way we can add terms together. So like, I eliminate the fraction completely where cross multiplying isn't necessary.
Oh yeah.
Other questions about how to get to those values? So once you're at this point, this should be the step then that we've done since October or November. And we've done in chapters 4, 5, 6, and 7, where you're now solving an equation that involves an x squared. And we started way back with factoring in chapter 4. Chapter 5, we were doing polynomials. Chapter 6, we were solving with those square roots. Chapter 7, we were doing the logs. All involve factoring as the last couple of steps to solve the equation. So if you're having a hard time with the least common denominator part, we can definitely work through more of those problems, and please let me know. But the factoring part, that should be the part that we've used since October through, that's about 6 months' worth of working on the factoring. So if we set this equal to 0, Caitlin, what do you get when you combine some like terms and set it equal to 0?
3x squared. Yeah. Plus 8x minus 16.
Right. So we have to subtract 4x and subtract 16 to get it to the other side. So now this type of factoring is using that AC grouping method, where you have to take the negative 16 times 3. What is 3 times negative 16? Sam?
48.
Yeah, negative 48. What two numbers multiply to be negative 48 but add to be positive 8? Isabella?
12 and negative 4.
Yeah, 12 and negative 4. So that would be 3x squared, taking your factor of 12x and negative 8x and writing them in the factors, kind of expanding the problem. And then there's a minus 16. How about a negative 4, not a negative 8? And then you look at what you have, you take out what the first pair of terms have in common, you take out the second pair of terms have in common, so this will be pulling out a 3x, pulling out a negative 4, and then pulling those front pieces together, grouping them together. So we have 3x minus 4, and then x plus 4. So that's AC grouping. Once you have it grouped and you have it factored, solve each one of those. So Kate, the two solutions would be?
X equals 4/3, x equals -4.
And then the last step is to check for extraneous solutions. How do you know if a solution is extraneous? Kate?
If it makes the denominator 0.
If it makes the denominator 0. So when you're dealing with fractions, if you have a number that makes the denominator 0, then it's extraneous. Not the fact that the number is 0, but when you plug it back into the denominator, it's making the denominator equal to 0. So if you plug in a 4/3, 4/3 plus 4 is okay, 4/3 minus 4 is okay, 4/3 squared minus 16 is okay. But if we plug in a -4, -4 squared makes 16. 16 minus 16 is 0. If I plug a -4 in here, -4 plus 4 is 0. So it's the number that makes the denominator 0 that is the extraneous value. And in that case, it's the -4. So cross it off. Or you could state that it's extraneous, but some way that you have to show that that is not the solution. So it's the number that makes the denominator 0. That's what is an extraneous solution for these type of equations. So logarithms, it can't be 0 and it can't be negative. This is whatever makes the denominator 0. Questions? So we're going to look at the one right next to it. It's kind of similar setup. I'm going to erase this part here just so that I have a little extra room. So this first denominator factors as x plus 3, x minus 3. And then we're using the least common denominator to help us eliminate the fractions or the denominator part from the problem. So the least common denominator, x plus 3, x minus 3. And both sides are getting multiplied by that. That keeps the equation equivalent. That also enables us to get rid of the denominator in the fraction. So essentially, you're working through this problem exactly like the problems where we're adding and subtracting the fractions together. Like you're looking at the common denominator, you're saying, what does my current denominator have, or what is it missing, and that's what you apply to the numerator. But this time, we're not keeping the denominator in the problem because it's an equation. We can eliminate it from the problem. So with the 8x squared over x squared minus 9, or x plus 3 over x minus 3, Izza, what would be left with that problem?
Just 8x squared.
Just 8x squared. So it has all of the common denominator. It doesn't need anything extra. Is it, how about the middle one? So there is an x plus 3 in the denominator.
You would do x minus 3 times 4x.
And then what does that become?
4x squared minus 12x.
And then the key thing is to remember that that
Oh, yeah,
minus
minus.
sign is in the problem. So minus goes with both of those pieces that we multiplied together. And then is it the last one needs?
2, yeah, you do 2 times x plus 3, which would be 2x plus 6.
Nice. So distributing the negative through and kind of combining like terms. 8x squared minus 4x squared is 4x squared. A negative 12x with the negative sign becomes a positive 12x. And then on the other side is 2x plus 6. Just be really careful with that negative sign. That negative really changes the whole problem, and you're going to get a different answer if you don't apply that negative to both parts that were with the 4x. So the 4x squared was negative, the negative 12, and the negative also now make it a positive 12x. So Sarah, if we set this equal to 0, what does that give us then?
It would be 4x squared minus 10, or plus 10x minus 6.
Good. So subtract 2x and subtract 6. Any questions at this point? So if we're factoring this truth, what could we do to factor this?
Well, you can either divide by 2.
Yeah, let's get that 2 out, so it makes the numbers a little smaller. Okay, and then we're dealing with a negative 6, so truth, the two numbers that multiply to be negative 6, but add to be added.
2
So 2 and 3, what else?
and 6 over negative.
6 and negative 1. So we would have 2x squared, 6x, negative 1x, and then minus 3. Maddie, do you have this factor?
Yeah.
What do you have? Just give me the factors.
Like the. What do you mean? Like.
So the number, what do you have in the factors once it like
Okay.
it's
Well,
factored?
I did it divided by 2, but
Okay.
So I have.
If you
so it would
divide
be
yours
2x minus 1.
Yep, 2x minus 1
And then x plus 3.
x plus 3. So the 2 goes outside, we factored that part out, that's the GCF. Then you get 2x minus 1 and x plus 3. So one solution would be 1/2, the other one would be negative 3. Does the GCF become part of your solution? No, it doesn't have an x with it. It was the GCF. Once you pull that GCF out, it like is done. You're done with that number. You made your value smaller. You're not using the GCF any longer. So Ryan, is there an extraneous solution?
Yes.
Yeah, but-
Because negative 3, when plugged into the top for the denominator, negative 3 plus 3 is 0.
Right. So if you plug that negative 3 in, negative 3 plus 3 is 0. If it makes one denominator 0, then it is not a solution. So cross off the negative 3, give the 1/2 box. Questions? So I'd like you to flip the page. And I know there's 2 on the bottom, but there's also 2 on the back page. I'd like to do the last one, number 4. So number 4, we have a fairly large equation. 2x over 3x minus 5, x plus 1 over 3x plus 5, and then negative 4 over 9x squared minus 25. See if you can start the problem. So this is the last one. It should be the last page of your packet. So Sam, the first fraction had a 2x over 3x minus 5. It needs a 3x plus 5. So when you FOIL that, what does it become?
6x squared plus 10x.
The middle fraction had the 3x plus 5, so it needs a 3x minus 5. And what does that become then?
3x squared minus 2x minus 5.
And that gets a negative sign in front of it. So that middle term there with the minus sign, that whole quantity is now negative. And then Sam on the right is just
Negative 4.
negative 4. So the denominator, it has all of the least common denominator in it, so it needs nothing. It's just the negative 4. So then be careful because subtracting this middle quantity here, every term gets subtracted. And this is where your signs could change with your factoring. So 6x squared minus 3x squared is 3x squared. 10x minus a negative 2x, that becomes a positive 12. That minus sign is distributing, so parentheses around that middle piece, that middle fractional values. And then a minus negative 5 turns it into a plus 5. So when you take the negative 4 over and you add it, you should have 3x squared plus 12x plus 9. And if you didn't get that, it probably has something to do with the minus, that negative sign getting distributed through all of it. Questions? So Jenna, what could we do to factor this? Yeah, take out a 3. And then Jenna, the two factors that make 3 are 3 and 1 that also add to be 4. This one you don't have to do the huge AC grouping process because it's just a 1 in front of that x squared. So you can just take those two factors, positive 3, positive 1, put them in your parentheses and then solve. So a negative 3 should be one solution and a negative 1 is the other. Are either of these extraneous? No. So if you plug them into the denominator, neither one of them are going to make the denominator 0. So 3 times a negative 1 would be negative 3 minus 5 is negative 8, and that's okay. So check them. Make sure that when you plug it into the denominator, it doesn't make the denominator 0. You don't always have to have an extraneous solution. There could be times when they both work. Every once in a while, they might both not work, and then you have no solution. Questions? So you have 11 minutes. You already have your homework. It's on the back of the worksheet from yesterday. So you're doing 1 through 18, and then the 2 word problems at the bottom, just 21 and 22. Those two go together, 21 and 22. So you can skip the middle 2 word problems, 18 or 19 and 20. I would like somebody to present tomorrow number 17 and then also 21, 22. They're kind of like paired together. Maddie and is it?
Which one do you want? I don't care, wait, what is it, 17 and 21? Is it 17 and 21?
It's 17 and then 21, 22 because those two problems just go together.